Bismillahirrahmanirrahim. We continue our Ionic equilibrium discussion with the basic salt solution. This is under hydrolysis of salts. We have discussed the acidic salt solution. Now we look at the basic salt solution. How to solve the problem for basic salt solution. Basic salts derive from strong base and weak acid. So in this example, we have sodium hydroxide as a strong base, acetic acid as a weak acid. When strong base react, it will form a very weak conjugate acid. But the weak acid will form a strong conjugate base. So when the salts form, CH3COO, Na is the salts for this reaction. So when the salts form, it will dissociate in water. Kita dissolvekan di dalam air. It will form CH3COO minus plus Na. CH3COO minus plus Na. And actually it is a pair of this one. CH3COO minus is a conjugate base for weak acid. Na plus is a conjugate acid for this strong base. Okay. Na is weak. Okay, dah baca dah. Sodium ion is a weak conjugate acid of a strong base, so it will not react. Remember, weak conjugate pair will not react. Only strong conjugate pair will react. So acetate ion is a strong conjugate base that formed from weak base, so it has a tendency to hydrolyze and accept proton from water. So when acetate ion hydrolyze, this is the reaction for hydrolysis. CH3COO minus is a base. It will accept one of the hydrogen from water. Then we get the acetic acid plus hydroxide ion. Hydroxide ion is quite strong base. So that's why this solution will be a basic solution. Okay. Now look at the pH calculation for basic salt solution. Determine the pH of 0.15 molar solution of sodium acetate, CH3COO and Na. Given the Ka for CH3COOH is 1.8 times 10 power negative 5. So how to solve this problem? First, you need to write the reaction equation. First, the dissolution of salts. Dissolution of salts is a full-headed arrow, means that if you have 0.15, you will get 0.5 for this one and 0.15 for this one. Then you just take this one because this one does not hydrolyze. You just omit this one. We just focus on this. Acetate ion will hydrolyze with water to form acetic acid and hydroxide ion. So we will do the ice table for this equation. Remember the concentration that come from this dissolution ataupun dissolution of salts is 0.15 for acetate ion. So like the previous calculation, this one 0, this one minus x, this one plus x plus x. At equilibrium, when the reaction finish, we will have 0.15 minus x. This is x and x. Then you solve for this calculation to find the OH concentration. To find the pH. pOH first. Then from pOH you get the pH. Yes, even though the given value is the Ka, but since at the equilibrium we have the concentration of hydroxide ion, so you need to find the Kb for this conjugate base. This is conjugate base of the acetic acid. Okay, so find the KB. Then you solve this one using assumption first, because normally a very low value will just dissociate a very low percentage. Normally the assumption is valid. Get the X. X is actually equal to OH minus hydroxide ion, because you refer back to the previous equation ya. Tengok dekat belakang tu is either OH or H plus. So X will become that value lah. Kalau dekat belakang tu OH, so X is the OH minus, concentration of hydroxide ion. Then from the OH, you calculate the POH ya. Ataupun daripada OH you boleh cari H plus. Daripada H plus you terus boleh dapat pH. Ataupun boleh juga guna OH, you find the POH. From this, remember pH is equal to pH plus POH is equal to 40. Yeah? Using that relationship from POH, yeah, 5.04, you can find the pH value. Okay. So I think I stop here for the determination of pH for basic salts. Yeah. Okay. Next, in the next video, we look at the buffer solution. Okay. Then we stop here. Assalamualaikum.